Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And I want to explain the very first example of exponential and logarithms. Having seen and understood the features, it is important that we go to example 1 and find out exactly what's happening there. And you're told in the same set of axes, sketch the graphs of y is equals to 3 raised to power x, 2 raised to power x, and 1.5 raised to power x. All these are exponential functions due to the fact that the index is actually an exponential. It's the one which is the variable. It keeps changing. And I just want to feature some um, I just want to tabulate this information, so to speak. Let us have x. Let us talk about this being y1, this being y2, and this being y3. So what is y1, which is equals to 3 raised to power x, y2, which is 2 raised to power x, and y3, which is 1.5 raised to power x. When x is minus 3, let's talk about minus 2, minus 1, 0, 1, 2, and let's reach 3. And let us, for once, get to understand what these values give us. In this case, when x is a minus 3, and I want to do a bit of calculations here at the peripheral, we're talking about y is equal to 3 raised to power minus 3, which is 1 over 3 raised to power 3 positive, which is 1 over 27. 1 over 27. Such a small number. When x is a minus 3, the same case happens, and you realize that this one is y 2 raised to power minus 3, which is 1 over 2 cubed, which is 1 over 8, which is 1 over 8. And definitely, you may want to talk of what is y when x is raised to power minus 3 in this case. So we're going to have 1 divided by 1.5 raised to power, let's call it a 3, and we're going to talk about 8 out of 27, which is 8 out of 27. I want to say something here. This is the smallest, followed by this, and of course, this is the biggest. Fine. If we want to probably, let's say, when x is minus 2, this is 1 over 9, this is 1 over 4, this is 1 over 2.25, because we are going to have 1.5 raised to power minus 2, which is 1 over 1.5 raised to power 2 or squared, which is this. So this one shows us a very clear picture that 1 over 2.25 is greater than 1 over 4, and both of them are now greater than 1 over 9. So we may not be having time to fill the whole table, but you can see I've explained what I wanted you to see, and I'll also display it in the graph. But let us just get to the next feature, whereby when x is 0, when x is 0, 3 raised to power 0 is 1, 2 raised to power 0 is 1, and anything like 1.5 raised to power 0 still remains 1. Let's go to when x is equals to 1. 3 raised to power 1 is 3, 2 raised to power 1 is 2, and 1.5 raised to power 1 is simply 1.5. Again, you can see now this is the highest, followed by this, and this is the least. When they cross over to the positive side of x, they interchange now the position. What was the smallest on the left when x was negative is the biggest when x is positive. And I want to just construct this graph with just those features displayed there. And I want to probably have something like this. When x is minus 1, minus 2, and 1 and 2, I would consider this to be 0.1, 0.1. And when x is minus 2, this is 1 over 9, a very small value. But when x is 2, when x is 1, this one becomes a 3. This is a 3. This is a 2. When x is 1 for this particular value, this one becomes a 3. So you'll have, but when x is 0, you'll have a graph that looks like this, like that. And this is just one graph. Y is equal to 3 raised to power x. I want to construct the other one using different color. And when x is a 2 for this particular equation, y is equal to 2 raised to power x, y is 1 over 4 rather. 1 over 4 is bigger than 1 over 9. So allow me to just place it over there without any mathematical meaning, because if we were to look at this, then this should have been 0.5. But anyway, I want us to just look at it that way. So when x is 0, y is 1, you can see. But when x is 1, y is 2. So it is higher on the left-hand side, and they are now equal when x is 0, and it is smaller when x is positive. And I want now to construct another graph here with a different color. I don't know whether I have different color. The graph of y is equals to 1.5 raised to power x. When x is minus 2, then we have 1 over 2.25, which is greater than 1 over 9, which is greater than 1 over 4, and it is 1.25. Allow me to put it there, and I know if this is 1, then this one does not really reflect the meaning I want to, or the value that I want to. But I want to show something. When x is 0, y is 1, y is 1. But when x is 1, then we have 1.5, which is just there. So this graph was giving us the higher value of y when x was negative, but when it comes to when x is positive, you can see it is giving us the lower values of y. So to speak, this is the graph of y is equals to 1.5 raised to 4x. That is the graph of 1.5 raised to 4x, and this is the graph of y is equals to 2 raised to power x. Please note, on the left, they are displayed this way. On the right, they interchange positions, and that is just like how what I wanted you to see. But of most importance, none of them will be 0, and as regardless of the value of x, and of course when x increases, they will all increase exponentially. But of most importance, you can see all of them pass through the point 0, 1, as explained in the previous video. All right.